I'm Kanako Ishikawa. I'm working for Lake Biwa Environmental Research Institute. Today's my topic is the ecological regime shift in the south basin of Lake Biwa, focused on the algal blooms and submerged macrophyte overgrowth. As Director Naito lectured in this morning, Lake Biwa is the biggest lake in Japan. The lake separated into two parts, the northern basin main basin and the southern small basin. The average depth is north basin is 43 meters and that of south basin is 4 meters. The city area is located in the south area, and main outflow is only Seta River and Kyoto Biwako Sosui Channel at the south. So the south basin is eutrophic and the north basin is a mesotrophic lake. The lake has been eutrophicated in 1960 to 1970s, but recently water quality has been recovered. The lake supplies drinking water to 14.5 million people in Kansai area, including Kyoto, Osaka, and Hyogo Prefecture. So, a long-term trend of total nitrogen have been decreasing in the south basin here, and the pink line shows the TN concentration in north basin, and green line shows that in the south basin. These three national and local organizations take water samples and analyze them every month. Each dot shows the annual average of 28 stations in North Basin and 19 stations in South Basin. Also, a long-term trend of phosphorus have been decreasing gradually in South Basin. The long-term trend of chlorophyll A concentration in South Basin is decreased in late 1990s, but it increased in these 5 years. The Secchi depth is gradually increasing, and suspended solid in the South Basin decreased in the late 1990s. And the early 2000s, and it has been stable recently. So please see the left picture. The sand bacterial blooms consist of Anabaena, Macrocystis, and Oscillatoria covered with the south basin in summer 1994. But recently, we have seen excessive submerged macrophyte and lake water became clear. That is to say, ecological regime shift occurred. It was considered that a serious drawdown in 1994 was a trigger of macrophyte increase. Submerged macrophyte area in the South Basin was less than 500 hectares during the eutrophication in 1974, but it expanded rapidly after 1994. The macrophyte was covered with a lake bed in 2009. And the massive development caused the disturbance problem for fishery, smells, and so on. Diving method for monitoring macrophyte was a hard job. Then we used EcoSounder in these years in order to follow the data in the last slide. We can see the distribution of height of submerged macrophyte. Also in the abstract, we showed the seasonal change of distributions in 2004. The data helps us to decide where we cut and remove macrophyte. Shiga Prefecture has been cutting and removing macrophyte enthusiastically since 2009 to reduce social problems. But the removed biomass was only 5 to 6% of the total biomass. It is not easy to take off. So we cannot know the precise biomass and the species composition with the echo sounder. We collected the Macrophyte species samples at 52 stations. The biomass monitoring started in 2002, and I joined the observation since 2007 with these environmental sensors. The most dominant species was Potamogeton machinus in red bar here, this species. The total biomass is increased between 1995 to 2002, but it didn't change between 2002 to 2007. While the percentage of vegetation cover increased, the total biomass in 2012 was only 30% of that in 2007, because phytoplankton came from North Basin in spring and cyanobacteria increased in the late summer. We are afraid the ecosystem would return from the clear water phase to the turbid water phase. Against our anxiety, the total biomass of Macrophyte increased again in 2014, recorded the maximum value in the history of the South Basin. These contour maps shows concentrations of dissolved oxygen distributions 30 centimeters above the bottom. Percentage of dissolved oxygen less than 2 milligram per liter was 27% of total South Basin area in 2007, and it decreased in 2011 and disappeared in 2012, but it increased again in 2014. We got a linear correlation between the dissolved oxygen at the bottom layer and the percentage volume infestation (PVI) of Macrophyte in water column. Some references suggest that the dissolved oxygen less than 4.3 milligram per liter is not suitable for physiological activity of fish, and the dissolved oxygen less than 2 milligram is a dangerous level for living benthic animals. For this result, we should cut the Macrophyte when the PVI is more than 58% in order to conserve fish and shells on the lake bottom. Moreover, multiple regression analysis with each species showed the dominant species of Potamogeton machinus, which is likely to cover the lake bottom, and Secchi is related to the dissolved oxygen concentration. The average chlorophyll A concentration was 7.3, 12.9, and 10.9 in 2007, 2012, 2014 respectively. Average chlorophyll A is high in the year when the Macrophyte biomass is small, but we could not see any linear correlation between chlorophyll A concentration and the Macrophyte biomass. Increasing standard deviation might indicate algal blooms in lentic area of Macrophyte overgrowth. So, to summarize, when the lake recovered from eutrophication, excessive Macrophyte propagation causes the problem of lentic algal blooms and oxygen depletions. The Macrophyte biomass reduced to 30% in 2012, but it did not return to the turbid phase. The stability of the ecosystem in South Basin is now very strong. So our future work is to clear to what extent can we remove the Macrophyte. It is well known that the macrophyte is related to the resilience between clear water and turbid water phase. So without biological monitoring and water quality monitoring, we cannot develop effective management method and further initiative to meet our goals for water and ecosystem restoration. Thank you very much.
Thank you very much, Dr. Ishikawa. Yeah, she still have the 7 minutes. Okay, please, Hans.
I'm curious, before the eutrophication of Biwa started, were macrophytes dominant before the algal blooms started in the lake?
Yes, we have a record before. I didn't show this. We have a record in 1936, and the biomass was around 2,000 tons. So it's almost the same as in 2012. So, but the species was different. The type of rosetta showed macrophyte was covered the South Basin.
And then the other question I had was fish habitat. The macrophyte. I would think that the macrophytes are good fish habitat. Are they?
Yes. Recently, our fishery has deteriorated, but before the macrophyte increase, some tiny fish, endemic species prone and increase, and it's a good habitat for their growth. So, and also we had a lot of shells, Secchi. So it's also the endemic species. So. It's not only the macrophyte increase, it is not only the reason macrophyte decreased the fishery, because we changed the water levels in 1992. We changed the law, so it is very complicated to find the reason, but yeah, the macrophyte is one of important issues.
Okay, how's okay? Okay. Any other question? Okay, thank you very much, Kanako.